Hello, everyone, and welcome to today's episode of the OWASP DevSops Show. Today, we're going to be talking about privilege escalation in the cloud. As we all know, organizations are increasingly using SaaS platforms and external clouds, and we are going to talk about how you can privilege escalate inside those clouds. Today's guest is Carlos Polop. Carlos has a degree in telecom engineering and a master's in cybersecurity. He has worked mainly as a pen tester and a red teamer for several companies, but also as a developer and system admin. Today, he's going to talk about his tool called PurplePanda, a tool that you can easily find paths to escalate inside the cloud. Welcome to the show, Carlos.
Thank you. Thank you very much. I'm very excited to be here.
So PurplePanda, what is PurplePanda?
Yeah. Well, it's an unexpected name for a privilege escalation tool for sure, but it has some reasons about that. But basically, it will be a tool to discover and print in graphs paths to privilege escalate. So if you want, we can start with this presentation.
Cool.
So yeah, the first thing that people ask me when I release this tool is, why did you call it PurplePanda? And well, I have these other tools which are called Ps that are able to discover privilege escalation techniques locally in different operative systems. And the thing is that I have been preparing them these last months to be able to find also API tokens and sensitive information. So the thing is that I was looking for an animal that eat peas, because the idea is that this tool is going to be able to take some of the tokens that the peas are going to find when you are trying to escalate privilege locally, and then it is going to do something with them. So when I search in Google animal that eat peas, the first one that appeared was a red panda, and I call it PurplePanda because I want people to know this is a tool for purple teams, not only for red teams. So if I call it red panda, probably blue teams didn't use it.
I like it.
But yeah, that's the only reason behind the name.
That adds up to me. The red panda, the peas, purple team, PurplePanda. I like
Makes
it.
sense, right?
Yeah, total sense.
So the idea, well, I have already said the idea. So you managed to compromise somehow a computer inside the cloud, a computer with some tokens. You managed to compromise some SSRF vulnerability. The thing is that somehow you get this token of a cloud or SaaS application, and then the first thing that you try to know with this token is, what can you do with that application? Which permissions do you have? And there are a lot of complicated things in this scenario, because, for example, people are very used, I suppose, to compromise Active Directory. Whenever you have this whenever you have access to the Active Directory, you're going to be able to get all the information from that environment. But in cloud, that is not that common. You cannot just access everything from one account. You will need to try to enumerate everything and see what you can access and what you cannot do, and then save that information in a database and inspect it for potential vulnerabilities. So this is what PurplePanda is going to do. It is going to take these tokens you have already found, and it is going to enumerate the API server and try to get all the information you can get with those credentials and print them to you in a nice graph database. So the resources that are already supported in PurplePanda are Google Cloud Platform, GitHub, Kubernetes with GKA included, Concur, Circle CI. But ideally, the idea will be to support much more clouds and SaaS applications, because doing this kind of pen test, I found that it is amazing how all these platforms are related. So, for example, you could have this Kubernetes environment running maybe on premises in your data center, but you have the containers images saved inside the Google Cloud registry. So anyone with access to that bucket is going to be able to compromise that image and compromise your Kubernetes environment. Or another example that we are going to see later is, if you have if you have a GitHub repository which is mirrored in GCP, and then you have a cloud function that is running that code, if you can bypass branch protections to that GitHub repository, merge in master, then when that cloud function is going to be executed with a service account on it, anyone with access to that GitHub repository is going to be able to escalate privilege to this cloud function inside GCP. So the more platforms this tool is able to support, the more privilege escalation you're going to be able to find across different cloud and service applications, which is amazing because if you want to do this manually, I can tell you that it is a real pain. If you need to enumerate everything in GCP manually, then go to GitHub, enumerate which can access what, then find out who can, like, doing that manually is horrible. And doing this with PurplePanda, you just execute it, leave it run for a couple of hours, and you're going to be able to see how you can go from one application from one platform to another. And that is I think it's amazing.
So, all right, I'll wait. I'll save my questions till you get
Mhm.
more into the demo.
You wait till the demo, or you want to ask now?
Well, so if you could just go back one slide.
Yep.
So I'm just trying to understand. So you have a AWS key, a key pair, and
Yeah.
you use PurplePanda to enumerate the permissions that these keys have within AWS, right?
Yeah.
And it sounds like it could also, like, how does it do that second bullet, privilege escalations across all the environments it has enumerated, all
Yeah.
the AWS environments, or it could, like, yeah, I think I'm just stuck there for a second.
Okay. So, well, you're gonna hate me because PurplePanda still doesn't support AWS.
Okay, forget AWS.
I'm working on it, but for example, if we take Google Cloud Platform, which is supported and I guess pretty similar to AWS, what it's going to do is, obviously, in order to enumerate GCP, you need some service account token, some credentials of a user to access the cloud, to enumerate it. And in order to enumerate GitHub, you need a token or some other credentials to enumerate GitHub. The thing is that PurplePanda, as it is, let's say, creating nodes in a graph database, it is going to identify that, hey, this source code inside GCP is mirroring this repo in GitHub. And then from the other side, you're going to find, when enumerating GitHub, hey, I have access to this organization, and this organization have this repo, and all these users can merge into this repo. After all this enumeration is done, PurplePanda is going to execute some functions that are going to analyze cross-platform relationships, and it's going to say, hey, do I have any user that can bypass branch protection in a repo that is mirrored in GCP, that is running in a cloud function, and that cloud function is running a service account? And if we find that complete path, it is going to create a relationship from the GitHub user to the service account saying, hey, you can privilege escalate here.
I see. So this is way more than just hitting the cloud provider's API server to figure out what those keys do. You have a full graph database that kind of keeps track of all these relationships between where a key is found versus what it may or may not have access to.
Yeah, exactly. Let's say that there are two phases. One is enumerate everything, and the next one is let's find the interesting information.
Right. Cool. All right, I gotcha.
Okay. Yeah, feel free to interrupt me with any questions.
Yeah, there's a few questions in the chat. I guess, do you want to, maybe we could just get these out of the way, and then when you get into the demo, I think there'll be new questions.
Okay.
Adrian is asking, does it support AWS EKS? Oh, sorry, Nancy. Yeah, let's start with the AWS question since we were just talking about that.
Yeah, it supports Kubernetes. So as long as you can access the Kubernetes API, it is supported. So EKS is going to be supported because you can access, in case you can access the API. You are not going, what PurplePanda doesn't support of AWS at the moment is that you cannot give it just a role, some credentials of AWS. But if you give it credentials, kubeconfig, to connect to the AKS Kubi API, it is going to enumerate that Kubernetes environment.
Got it. So it knows how to speak Kubernetes, just not the AWS part.
Yeah, exactly.
Okay. And then the next question from Adrienne, if it works with Circle CI, I guess it is via an ORB. Is it possible to use it somewhere else, like Jenkins, if you want to mimic what the ORB does?
So yeah, my idea is to integrate more platforms. Jenkins is on the way, let's say. Obviously, integrating one of each of these platforms, I need to study the API. I need to study what I need to get, prepare everything. It takes a lot of time. Ideally, yes, I want to integrate any kind of CI/CD platform and any cloud, so we can find all these relationships. But that is working out slowly. I want to focus now on AWS, to be honest.
Cool. All right. We're good now. We can keep going.
Cool. Okay. So how to use it? Well, you can just install it in via Python environment or run a Docker. Well, let me show the GitHub repo, probably that will help to know where you can find this. So in my GitHub repository, Carlos Polop, PurplePanda, you can find everything here. Here you have the installation steps via Docker or local install. So something I want to highlight a lot is that in order to use PurplePanda, you should know what you are doing. PurplePanda is not going to do any kind of write, execute, or abusive thing. It just reads from APIs and saves in a database, so it's not going to destroy anything. But if you don't know what you are looking at when you take the graph, you're not going to identify the privilege escalations or know how to exploit them. So in order to do that, what I recommend is to take a look to Hacktricks, where I have put information about Concourse, GitHub, Kubernetes, Google Cloud Platform. Here we can find all the information about Google Cloud Platform I have. And actually, just to show one of them, we can see this is kind of interesting. In GCP, there are thousands of roles, thousands of permissions. And here I have collected the ones that I know that will allow you to escalate privilege via EAM, resource manager, deployment manager, compute, container, even via storage. Because it is interesting how platforms are related across them, but also internally, it is interesting how you can escalate privilege inside a platform just by using a resource and getting some new credentials, using them to access another resource, and just continue pivoting like that. So here I have collected all the, well, GCP's permissions I know that will allow you to just pivot inside GCP and escalate privilege. So yeah, my recommendation is, in order to use PurplePanda, first of all, read the documentation I have about how to abuse the platform you are going to be enumerating. Here we have about GitHub, Kubernetes. Yeah. Well, also I have information about Circle CI, Concourse, and more. I think I have integrated even more things here. We have Gitea, Jenkins, Apache Airflow, Atlantis. Well, and I have more in the part that people cannot see. So I'm actually pretty involved at the moment in the cloud CI/CD environment, and I will be releasing methodologies to attack each kind of platform. So where we are here. So okay, now we are going to start with the demos. For the demos, I have populated an anonymized database with information about GitHub, Kubernetes, and GCP. So we are going to see some queries. We are going to start with GitHub. But first of all, I want to clarify something. As you may imagine, just one platform, just one of these platforms, are going to have a lot of information. If we just try to print everything inside a single view, we are not going to be able to find anything interesting. Or if you try to analyze each node one by one, it's going to take you a lot of time to find interesting things. So what PurplePanda does is when it finishes enumerating the platform, each platform, it is going to generate a CSV, that is going to run some queries to the database and save them in CSV files. Why? Because then the analyzer, which can be a red team, a blue team, whatever, is going to be able to find interesting information that then he can focus on in the graph. So, for example, we can see in GitHub, we can see where its leak appear, the org administration of the organization, because then later we can check how they can escalate privilege, or repos each user can merge. The idea is to find some highlight information and then go to the graph to analyze it further. I'm not going to show any CSV because I have anonymized the information, and we will be looking at tables of random data that doesn't make any sense. But just so you know. So let's start with the fun stuff. So we have run PurplePanda, we have enumerate everything, analyze everything inside the database, and we have taken a look to the CSVs and find some interesting information we want to know from GitHub in this case. So, for example, let's say I am an attacker and I compromise the user called Carlos Polop inside an organization, and I want to know, hey, what secrets inside GitHub can this user steal? So let me show you the root. Well, I didn't. Well, no worries. We can go to the Neo4j. Cool. We can go to Neo4j Bloom, which is the application I'm going to be using to watch these queries. And I can see that here I have my username, which is name, Carlos Polop, the one I have compromised. And here I can see all the secrets I'm going to be able to steal. Here they are actually, yeah, can steal secrets. Okay. Well, I have changed here the names. I have anonymized the names of the secrets, but this is pretty interesting because if you have compromised a user, just running this, you're going to be able to see, hey, maybe this is called AWS token. So you know you have access to that secret. You know which secrets you are going to be able to steal for just from just a single user.
But also, and so just back to Neo4j, you export a CSV file, right? And you're using Neo4j Bloom to visualize the graph in this context, right?
Yeah. Okay. Yeah, exactly. So in order, if this is explained in the install instructions of PurplePanda, but I recommend, because I want to create a web application where you can see this information, but I didn't have the time yet, and I'm not very good coding web pages. Neither I like it. So
I think there's a D3. I think there's an easy D3 graph visualizer. I don't know. I think there is. Maybe.
You mean the JavaScript library?
Yeah.
Yeah, but you still need to code something.
Yeah, totally.
Yeah, no, I need to investigate it. Yeah, I know a couple of libraries, but I don't enjoy preparing GIS, so I just try to. Well, Neo4j Bloom works, and if you install
it works well,
yeah, it works well. And if you install in your desktop Neo4j desktop, you are going to install the Neo4j database, the browser, and Neo4j Bloom all together. So it's actually kind of easy, let's say. Totally. So that's why I'm still using this, but yeah, I need to prepare this web page. So let's imagine we continue with this Carlos Polop weird guy, and we know now which secrets we can steal. If you go to Hacktree, you can find how to steal GitHub secrets in a very easy way. But let's see now to which repos this user can merge. So here, well, in this case, my user was administrator of the organization, so I'm going to be able to merge in all of the repos. But it's interesting to know that this query means which repos this guy can merge, not can write. This means that PurplePanda is not only going to see where its using is going to be able to write, but it's going to analyze the branch protection, and it's going to check if the user or each user discovered can bypass the branch protections and merge directly to master into that repo. So if we take a look to some of these relationships, as branch, no, this one can merge. Yeah, here we can see that the reason it is always going to tell you the reasons why you can do things. So in this case, we found a branch protection that doesn't enforce admins. So as my user is administrator, I will be able to bypass this branch protection and merge inside the repo. So yeah, it's interesting because we are doing some intelligence inside each platform and then across platforms. And let's check one other. Yeah. So I have already talked about this possibility before, but we are going to see it now inside a graph. So we said we have enumerated GitHub. We have analyzed branch protection bypasses. And we have also enumerated GCP. This query, this very, very, very simple query, is going to be checking all the principals that can bypass branch protections, merge into a master branch of the repo, which is being mirrored somewhere, in this case in GCP, which is being running by something, in this case a cloud function, that is having a service account attached to it. And here we can basically see that, hey, this guy with this full name, which is followers URL, which is Carlos Polop actually, can previsk to this service account. And here we can see potentially the reason. Is also anonymized, but he can merge into this repo name, which is mirrored by this one, which is used by this cloud function, which run the service account. So we can see here how we can escape from GitHub and compromise GCP.
Wow, and it knows, so PurplePanda knows like all the super privileged accounts, right? So it has that, it knows that that's like the end game, right? That's root essentially in the cloud.
Yeah.
Okay.
We are going to see them later how we can check for previous escalation inside GCP. But yeah, PurplePanda is going to relate with other principles in other clouds. Related to the question, it's important to know that depending on the permissions of the token you give PurplePanda, it is going to be able to enumerate more or less things. So for example, if you're not an organization administrator inside GitHub, you're not going to be able to see the branch protections. So PurplePanda is going to do some assumptions, like if you can write, you can somehow manage to bypass. You can modify a little bit that in the parameters to PurplePanda. But it's important to know that because maybe GitHub is not that interesting, but in GCP, if you give a service account that doesn't have access to anything, you're basically not going to be able to enumerate anything. So we will also talk about how PurplePanda can try to bypass this in the future, because these have a lot of work to do.
Yeah, this certainly looks like a lot of work.
So Kubernetes, again, PurplePanda is going to analyze Kubernetes, is going to get advanced resources as possible, analyze the roles, the cluster roles, the bindings, the cluster role bindings, and try to find privilege escalation inside Kubernetes, and also from Kubernetes to other platforms. Again, it is going to start giving you some CSVs with highlighted information. You can just take a look and then go to the graph to focus on what you want on how you can attack Kubernetes. So I'm going to run some queries. And when we are going to find some interesting information, not everything inside PurplePanda is about direct privilege escalation, but more about pen testing in general. So here we can see, like, you go to do a pen test, you have this huge Kubernetes environment or several Kubernetes environment with several namespaces. And one of the first things you should try to find out is which pods are being exposed to the internet, because that's how problems might come in. So what this query is doing is, hey, let's find all the service and ingresses that are being exposed, and then let's find all the pods that are using those services. So for example, here we can see that there is some ingress that is being used by this service that then is this service is being used by these pods. This means that these pods are going to be somehow exposed to the internet via this ingress, which is interesting because here you can very easily find where you need to focus on from an external point of view if you want to attack the Kubernetes environment. I also have a query out there that is similar to this one, but is also going to filter by privileged service accounts running inside pods. So you will be able to see that an ingress is being exposed in a service that is being exposed in a pod that is being exposed in a service account that is privileged because it can escalate privilege somewhere else. And that way you can just know where you need to focus from an external point of view to manage to compromise everything inside Kubernetes. And also the graphs that it creates are very beautiful with a lot of colors. Also, well, this is principles that can escape. This query will show us. Well, we can take a look. Also, it's interesting. Internally, if you get some kind of privilege, well, let's start again. If you manage to escape from a pod to a node in Kubernetes, in several cases, if default options are being used, you have potentially compromised the whole Kubernetes environment. If you want to know why, you can check it in Hacktricks. So that's why I found this query so interesting. I'm going to searching for service accounts that have some kind of permission that are going to allow them to create somehow a pod or something that is going to have enough privilege to let it escape to the node. So here we can find all the principals, and with principals I mean service accounts and users or groups that are going to be able to do that, escape to the node. So if you manage to compromise any of these accounts, you will probably just compromise the whole Kubernetes cluster.
Just a question on the how you got this data. You had a kube config and you had no idea what privilege or what that kube config had access to across the cluster, correct?
Exactly.
Okay, and so you just kind of you enumerate every single thing it has possible access to, and now you're trying to create this pattern of like, how valuable is this file or is this credential?
Exactly. I had this trouble when doing pen tests that I will find these kube configs, and then you start enumerating it by hand, trying to guess what
Get
is
pods,
there.
yeah.
But that is very annoying doing manually.
Right. So it just does like kind of a kubectl sort of command line querying, but just automatically get all pods across all namespaces, see how far it can actually go. And then you just present it all in this like very helpful graph environment where you can kind of, okay, I gotcha.
Yeah.
So if you had not a lot of nodes here, then probably the kube config is very restricted.
Yeah, exactly. And that's a problem because, for example, if you are trying to find previous escalations inside Kubernetes, but you don't have access to read the roles or the bindings, it's going to be very complicated.
Yeah, right. You need to find another kube config.
Yeah, probably. So something good about Kubernetes in that case is that even if you cannot read those permissions, you can still read your own permissions, and PurplePanda knows that and is going to exploit it. Did you know this kubectl auth can dash dash list that will give you your permissions, even if you don't have access to read the roles and the bindings. So PurplePanda is going to print you if you can previous using those things. And in the future, what I would like to do is, hey, if I discover that I can escalate privilege, why don't PurplePanda escalate those privileges, get the new token, and re-execute everything in a loop with some kind of limit or something? So you just need to wait, and PurplePanda is going to give you all the information it can retrieve just by exploiting those privilege escalation paths that it is finding.
Yep,
That would be
got
pretty
it.
cool. Yeah, another query. Let's get one more interesting. So you compromise somehow, you enumerate this Kubernetes environment, and now you're interested in, okay, let's say that I have already compromised all the Kubernetes, I have exploited everything, but I want to go further. I want to escape from Kubernetes. I want to try to do something else. So here we have a query that will give us the information about all the service accounts in GCP that we can exploit, because in GCP there is a way to say that that a service account inside Kubernetes have, let's say, some kind of equals inside GCP. That means that the service account in Kubernetes is going to be able to impersonate via workload identity the service account in GCP. So this is going to give you that information. So you know that, hey, I have this service account in Kubernetes. Cool. Now you have this service account in GCP. You can continue exploiting. Well, you can continue the exploitation inside of it. And here we can see, well, here, and maybe, yeah, the summary. The keys was given workload identity to access. Yeah, here, well, always we are going to find some information about the previous escalation technique inside the relationship. Cool. And even if PurplePanda doesn't support AWS, there are ways to give AWS permissions inside Kubernetes. So I have already parsed that information, and you can see how to previous to AWS. You are not going to be able to see with PurplePanda what can those compromised AWS roles do, but you will be able to know that, hey, you can escape. So
there is a Python script called enumerate _IAM that I think does some light work at hitting the AWS API server to see what those credentials can do. I don't know if you've ever used that, but it does work. Times out a lot, but it does work a little bit. So if you did have AWS credentials, there are some tools out there that could help you maybe enumerate some of the permissions that those credentials might have access to.
Yeah, this month I want to be very focused on AWS, and I want to check these kind of tools, because before creating my own tool, I prefer to just check
Sure.
all. But yeah, that's actually the idea. Like, okay, I have access to this AWS Iron role, so what can I do? If a tool can give me that information, I can just export it to the graph. That will be pretty awesome.
Yeah, and maybe you could. Yeah, I'll link it in the chat. So.
Okay. So the final thing I want to present. So Google Cloud Platform. Comparing this platform with GitHub and Kubernetes, you can imagine that Google Cloud Platform is pretty huge. So I support more than 10 resources inside Google Cloud Platform, but there are many more. And if there are many more, this means that there are many more ways to try to escape or escalate privilege inside Google Cloud Platform. But PurplePanda does its best in order to get the most common ones and then try to find the ways to, well, to escalate. So again, when running PurplePanda, you are going to end with some CSV that highlights interesting information, and then you go to a graph to start checking what you can exploit. Just like with Kubernetes, there are query that can be used to check for open firewalls that are being exposing things to the internet. Because if you find a firewall that is being used by a network, that is being used by a subnetwork, that is being used by a computer, by a virtual machine, well, you found a virtual machine that is being exposed to the internet. So for example, here we can see that we have a firewall that is exposing to all internets the port 22 that is being used by this network, that is being used by this subnetwork, that is being used by this computer. So you can think that this virtual machine, this compute instance, is going to be exposing port 22 to the internet. So this is pretty easy. This makes you very easy to visualize what things you have exposed to the internet. I don't have many compute instances in the thing I have enumerated, but here we can see a clear path of finding out these things that as a pen tester you then need to focus to try to compromise the exposed thing. Cool. Another thing that isn't recommended at all inside GCP is that service accounts inside a project should never, if possible, and this is not always possible, should never have privilege over other permissions, because that's the main way people is going to escape from one GCP project to another one, by just compromising this, by escalating privilege inside the project, compromising the service account that have access over other project, and then pivoting to this other project. So here we have a query where we can see service accounts inside GCP that have access to other projects that aren't their own. So for example, here, well, as the names are anonymized, this doesn't gives us much information. But here we can see that, hey, this GCP service account have access over this, for example, GCP secret, which is in a different project, or over these. Oh, these are secrets. Secret. Okay, or these service account, these three service accounts have access, some kind of access. This means that it has a role over this project in this case, which is pretty huge, because if you are giving a service account some specific role over that project, that means that it is going to have that role over the whole affected resources inside the project. So yeah, this is a way to find cross permissions in GCP.
And the if you go back to the graph, the isolated red privilege dots, what is going on there? They're just not, they have no connections?
These are a very interesting, that's a very interesting question, to be honest. Let me show you the query. So this is something I noticed yesterday night when I was reviewing the demos, and I couldn't find out why is this query giving me things that aren't related, because it doesn't make any sense. So what this query is doing is, hey, give me a service account that has a role over some GCP thing, but I want it to be part of a project, but I don't want it to be part of the resource, and I don't want that the resource is part of the same project that the service account is. So it doesn't make any sense that it is giving me a service account that doesn't have any relation or any resource. No, actually, Actually, it is. Okay. No. I think what we are seeing here, but this has to have some role. Okay, I'm not really sure. But these dots are probably false positives that you don't need to check.
Okay. So you're basically saying they have no resources assigned to them, and they're
Yeah.
not. So it wouldn't make sense that they would even exist in a GCP project, because theoretically there should not be accounts that meet those conditions.
If you're meaning that, yeah, if you have service accounts that doesn't have any kind of permission, don't
Right.
you don't need them. But let's consider something. Maybe I was given an account that didn't have enough permissions to enumerate all the resources and find out which resources can the service account access, if that makes sense. Or
Right. So that's where you're saying it's a false positive.
yeah, or another thing in the same line, we in GCP you don't say this service account has access to this resource. You say this resource can be accessed by these principals. If PurplePanda doesn't support a resource that is giving access to a service account, maybe we are able to find the service account while enumerating them, but we don't know what permission this service account really has because we didn't enumerate that other resource.
Mm-hmm.
So that's where improving PurplePanda comes in. I need to check the most resources as possible, but also if I am able to find privilege escalation paths and I can exploit them and rerun PurplePanda with the new privilege, I will probably be able to see more relations and we will probably be able to exploit more misconfigured permissions. If that makes sense.
Yeah.
So when you're trying, I was comparing this tool with Bloodhound, and the first thing that a person does when he gets Bloodhound is, hey, give me all the ways someone can escalate privilege to the domain admins. No, so let's say that the equivalent to a domain admin in GCP will be the organization object. So I was thinking, hey, why don't I get all the users that can privilege escalation paths until the organization? So that's what this query is doing. We are going to find all the ways principals discover are going to be able to escalate to the organization object. This means that all the people here, and this can be service accounts, groups, users, are going to be able to compromise the whole GCP organization, which is pretty cool. In this case, we can see that this is a Google group is going to be able to escalate privilege over the organization and therefore compromise it. Here we will see. Yeah, in this case, I am roles update direct role to we have this role that is granting us the permission to compromise the organization.
Just a quick, maybe stupid question. The naming, is that just like the last 8 digits of the key? 8 characters of the key?
No. This will be, you can check here the email, the display name, the name. I just anonymize this data.
Oh, okay.
So this is,
so it would actually be really well-formed data, like it would have, okay, all right, got it.
Yeah, here you will have Carlos Polop at email.com, Carlos Polop, the display name. You will have all the proper values, but I just randomize the data to not disclose information.
Yeah, I was like, I thought it was a key or some key material, and I was like, oh, looking that up is probably going to give people a headache, but I get it now.
Yeah, no. The data will be correct. that's why I'm not showing any CSV, because we are going to see a lot of random characters in a CSV, and that is not beautiful at all. But yeah, all this data and in the CSV will be the correctly formatted usernames, organization names, and all these things. Cool. And the last query I want to show will be this one, but might take a little time. So I want
So while
to.
that's running, yeah, we
Yeah.
could hit some questions if you wanna.
Okay. Okay.
I'll wait till you get it started so you could, in case it takes a few minutes to run.
Yeah. It is running.
Oh, okay. Okay, so let's start from Adrian has another question. I think it's comments, but it's probably a good thing to discuss. So he responded, so I must force my developers to not only use MFA, but also sign their commits and make the CI ignore any changes that does not come from a signed commit. I think this was back in relevance to the first part of the demo you were talking about with GitHub branching and stuff.
Yeah, that will depend. I mean, configuring GitHub signing can be a little bit of a pain. But if you can do it, obviously, from a security point of view, will be nice. But let's keep in mind that we are supposing that somehow, in order to enumerate GitHub, the attacker must have compromised something. If he has compromised one of the developer's computer, he's probably going to be able to sign the code. So that is not going to prevent the attacker from abusing those permissions. And also, in another scenario where maybe he has just stolen some kind of token or credentials without the SSH key to sign to sign the code, maybe you can prevent a previous escalation of running into master with signing code, but you are not you are not preventing the secrets of you're not preventing secrets of being stolen. What I mean is that, as far as I know, if the developer or the credential he has managed to compromise have right access over the repo, even if the commits aren't signed, he's going to be able to create a branch with a GitHub action, putting the secrets inside of it, and as it is in a different branch, it is going to run and exfiltrate the secrets. So signing is a way to prevent the main branch from getting compromised, but you are not getting that much prevention from other attacks like stealing secrets, or if your developer gets fully compromised.
Makes sense, yeah. There's two other comments that I think are good to address. So Security Grit says, good tool to scope an incident. This account is compromised and they can get to all these resources, and follows up with, also might be useful before a company merger to see where the other company has excessive access to clean up. I think that's true. I mean, it just makes a lot of sense that you'd want to see all of these different pathways across clouds in which you can kind of compromise a SaaS or cloud environment. So
yeah,
it's kind of like Bloodhound for cloud, though, right? It's like,
yeah, that's the idea.
yeah. Well, this looks like quite an interesting chart here. So or graph. So what's happening here? It's like an art project.
So yeah, let's take a look. So okay, here we have an account. Previously, we have taken a look to, hey, which principles can compromise the organization. From a blue purple team perspective, that's interesting because you might find people with excessive access that you didn't know about. But from a red team perspective, maybe that's useless because, okay, those users can compromise the organization, but I don't have any of those. I haven't compromised them. I will probably have compromised 1, 2, or 3. So the idea is, why don't you give me all the privilege escalation path that a user can follow. And in this case, we can see like, okay, if this user can compromise this other user, that can compromise this other user, that can compromise this other user, we are going to be able to see the full path of compromise that a user is able to do. Even if he cannot get to the organization object, maybe you can compromise the whole project or even across projects. That's the idea of this query. And I also forgot to mention where I'm taking these queries from, because obviously all of this is open source. So if you go to the repo, you will see the Intel folder, and then you find its platform. If you go to the how to use Markdown inside its platform, you are going to actually find all these queries. So, for example, the full previous path from someone, you can find here the cipher query that it is running underneath. So in order to run this in Neo4j Bloom, all you need to do is to copy paste that query, just add it here, just copy paste it here, put the search phrase, the description. Actually, all that information is given here, the search phrase, the description, and the cipher query. And just configure it that way, you're going to be able to execute it from this nice search box, and this will give you the details. So yeah, here we are saying the full previous escalation path of a user.
Cool.
So now I'm going to get to some conclusions. I don't know if you have any other questions related to this.
There's another question from Adrian asking, does this only export to CSV?
It depends. PurplePanda by default is going to create you these CSVs because there is some data you need to look at it in a table and not in a graph, because it's much easier to find weird things in a table in a fastly manner. So PurplePanda is going to create you these CSVs. But don't forget that all this information is inside a Neo4j's database. So if you just come if you come here, you can, for example, just open Neo4j browser. Again, this is Neo4j desktop, the thing I used to install Neo4j and Neo4j Bloom. And you could just copy paste the cipher queries I just presented to you here and get all the information and just dump them. So if, for example, I do match return unit 10, let's suppose that this is a query I'm very interested in. I can just export it as PNG, SVG. Somewhere, I promise, there is some JSON and CSV here. So you can also dump all this information. Cool. Do we have any other question in the?
No, just Adrian also says if you come to Barcelona, let him know. He will invite you for a beer.
Cool. I write that down. Cool. So, well, here I just tried to give a very brief view of PurplePanda. I run maybe 4 or 5 queries of each platform, but I have prepared in the repo tens of queries for each platform. We generate also maybe 10 CSVs per platform, and we have 2 more platforms to check, which are at this point Kubernetes or CI, and I hope I will be adding more. So if this was a very brief view of the tool, if you're interested in knowing more, just run it and start playing with it. It's kind of fun to find all the privileged ways you can compromise an organization with. So some to-dos. Obviously, I'm working on AWS, but I also want to integrate other CI/CD platform like GitLab, Bitbucket, Jenkins, Drone. I have a list somewhere. Yeah, I also want to create a
Do,
web page. I like Neo for JBlue, but I think it will be much awesome if instead of asking people to copy paste the queries, I could just give a out of the box prepare web page where people can just click and start taking a look to the results of the queries. That will be much easier. And any good idea. I'm very open to collaborations with companies or with people that is interested in this tool and want to improve it or whatever. So anyone interested, just let me know.
do you have I'm just looking on GitHub right now. Do you have any active issues, or do you have like a backlog of things that you want to do where people, if they want to contribute, can start to understand how they can contribute? Or what, how, if somebody wanted to contribute, how would they get involved?
Yeah, that's a good question. So in the main folder and inside each platform folder, I have these to do files that indicates things that needs to be done in each in each platform. For example, in Google we can see a lot of things like Chef, BigQuery, Firestore, Cloud SQL, Cloud. So yeah, in each platform you have a to-do file. But also, for example, if someone wants to integrate Jenkins, obviously there is no to-do file for Jenkins because there is no Jenkins folder. But it will be nice that he can just take a look to maybe Circle CI or Concourse and just mimic the information we are taking from them, but for Jenkins.
And Elise Nielsen is asking, how about Azure? Is that a backlogged issue too?
Yes, it is. but but I want to integrate AWS first. And I'm gonna be honest, I have been integrating tools as I have been needing them.
Sure.
So yeah, if at some point I have several pen tests I need to do in Azure platforms, I will probably integrate it. But until then, I just give priority to the things I need to use.
Cool. Lots of Security Grid says excellent tool. Thanks. This looks like an enormous amount of work. And thanks for coming on here to show us how this works. This is definitely valuable for anyone who is in the pen testing space or even on the blue team space, right? You want to understand the blast radius of a lot of your cloud projects. There's not really a great way to do that now that isn't manual.
Yeah.
So yeah.
Well, no, thank you for everyone that has come to take a look to this talk. Before finishing, I definitely want to give some acknowledgement because there is some people that has been helping me. Mike helped me getting started with Kubernetes security. Duncan helped me getting started with GCP security. Bea helps me with all these presentations. She designed the PurplePanda logo, the Peace logo, and What's for Hack is my CTF team, and they also help me with all security related things. So yeah, thank you to everyone that come today also to watch this talk.
Yeah, thanks for being here. Any more comments? No, everyone's pretty excited about this tool. So thanks for being here, and that's it. We'll see you all next time.
Okay, my pleasure. Thank you for inviting
All
me.
right. Yeah.